Okay, today on the bench I have this vintage percolator that a customer sent in, said it's not heating up, and she wanted to know if I can fix it. I told her I don't usually, don't usually work on these kind of devices, but we're going to see what we can do. Oh, you see some weird thing. I don't know what that bead is in there. That's kind of strange. This was in the bottom of the bag, and I'm like, what is that? And then when I turned it over, I found out what that is. It's one of the legs. Apparently, they're like some kind of cardboard, heat-resisting cardboard, and it was riveted on there, and it just got damaged in shipping and came off and broke off. So I don't know if that's all the pieces. It looks like it is, but I'll have to see about making something for that if we can get it, if we can even get it working. Okay, what we have is a General Electric. Says do not place pot in water. If pot does not heat, remove the cap and replace fuse. Category number P86P26, so it has a fuse. And the pot itself is cat number 119, it looks like a 9, it might be a 118. I think it's 119P101 right here. Looks like 400 watts, 115 volts, and made in Bridgeport, Connecticut, and Ontario, California, USA. Okay, again, I'm not sure what that thing is in there. Let's see if we can figure that out. This is part of the unit, but I don't understand what that is and why it's there. Maybe it measures the temperature of the water at that point. Could be a water thermometer. All right. So we know it's probably the fuse, now that we know that it has a fuse. So we have to figure out how to take it apart. It looks like the bottom just pops off, like it's just compression in there. So we'll assume that, because there's no screws, and it says to replace the fuse, unless that unscrews down in there and that takes the bottom off. That's possible too, because that looks like a different metal than the aluminum or stainless of the canister. And it's definitely not the same kind of metal. The heating element is in there. It's weighty, it's got some weight. Really nice logo on there. She loves the pot, so she's really hoping we can fix it. I noticed two different kinds of screws, but that one might be heat temperature resistant, that one down there, and this one here is just flat screws, so they hold the handle on. Again, it has looks like a heat resistant nut there, and it comes right on through the handle, where the other one just screws into the handle. So, and the other one looks like stainless or just plain steel, and this one looks like some kind of carbon, like tempered steel, something that would hold the temperature better. Still, that's just so weird, that element there. That's just a strange place for an element. Okay, well, first thing we gotta check is the line cord, make sure the line cord's fine. I'm sure it is, but we'll go ahead and check continuity, make sure that the voltage is getting through the line cord okay. This one's riveted together. Usually they're screwed together so you can replace the tip, and this one you can't. So let me set up my meter and we'll check this and then we'll continue. Okay, we're gonna check this cord for continuity. Huh. Well, we may have a line cord. Oh wait, I think I've seen some. There we go. But boy, that's high resistance. That's weird. That is really weird. Oh, I'm not getting reading again. All right, there it is. There's quite a bit of resistance in there. Might have to spray some contact cleaner in there and clean it out. Okay, let's try this one. That should be this side. Yep. That's better, 2.4 ohms. Okay, but this one is weird. I'm getting high resistance there. I think the problem is this cord. Yeah, see, that's 100 ohms, almost 200 ohms. Jumping all over the place. I'm thinking this cord's broken. Probably right here where it connects. And let's do this a different way. Well, before I do that, let's check the heating element in here and see if we get a reading across here. No, we're not getting nothing across there. Okay, so now we can do what I was going to do. I'm going to plug this here, and I don't know which side that is anymore, but we'll find out, and push that on there a little ways and see what we get. Okay, that's going to go to here. And we'll bring this one, oh, it fell off. Put it back on. Oh, okay. Yeah, that's weird. We're not getting that. Oh, it came off there too? No, it didn't come off there. So that's not making contact in there. I have my suspicions about this cable. And if I put it in there. Okay, so that don't work. Let's try it this way. The meter's working. Yeah, I have my suspicions about this cable. Let's see if we get some voltage through it. I'll put this on right there about, let's see, some kind of voltage reading here. It's on AC volts. Okay, we got 39.6 volts going in. Get rid of these. We got 4 volts coming out. I'd say we got a problem with this cord. Well, I'll be, unless this is a resistor cord. I don't think it's a resistor cord. No, it's just a rubber cord. Eight watt. Number 6. 10 amp, 125 volt, 5 amp, 250 volt. It's just a standard cord. Let's see if we can somehow move the cord around and find out where it's broken. It doesn't seem broken. It seems like it's just not registering the right voltage. That's so weird. I'm going to check my adapter here. It says it's putting out 39.6 volts, so let's find out. Yeah, 35.5 according to the meter. 39.6 according to that. That's a transformer, so yeah, it could be a little bit of resistance. So the cord is bad, we know that. I'll have to find another cord, but before we go any further with that, we need to find out why we're not getting no reading on this. Let me shut this off. I would imagine it's that fuse, unless the heating element has some really serious high resistance, but I should be reading something. Should be getting at least, you know, something, meg ohm, something. I'm not getting nothing. It's like I'm not even touching anything. If I even just touch across them, I get a reading, right? My body, I should be getting a reading here. So I would say the fuse is blown. Cord's bad, fuse is blown. That's probably why the fuse is blown. So let's see if we can get the bottom off this thing. Looks like there's a pry spot here, but it's right where that other leg is, and I don't want to pry on that because we already know what happens to those legs. Let me see if I can just pull. No, can't just pull. Well, that's just kind of weird that they would line that up, that slot up with a leg. Like you're going to pry on a leg. Maybe I'm prying this one, it's broken off anyway. There we go. Yeah, I don't like that idea of prying on the leg. That's kind of stupid. Well, so where's this fuse? Oh look, piece of mica. See that? That's mica. It's hard to see, right? And that's mica deteriorates. Gets what's called silver mica disease, and that's a heating. That's it. That's what's in here. This is a layer of mica, all the way around insulator, and they use it to make to insulate coils and such. And this has a clip that's holding it on. I'm assuming this would be the fuse, and it don't look blown, because if it was blown, this is going in here, and it's supposed to come out through here. This is the main wire coming in, so that's probably, this is probably the fuse assembly that goes inside. I say probably because I've never worked on one of these. So let's see if we can find some continuity somewhere in here. You won't see the meter, but you will hear it if it beeps. That's assuming I can get it on sound. There we go. Let's see what we got going on here. So if I touch the, and get this a little closer. Hold on, I'm going to move the camera. Okay. Sorry about that. But now you can see. All right, so if I touch that, you hear it. Okay. So now we want to look at this element here. It goes in here, see? And it should be coming out here, and it's not. So this is the actual fuse is inside this mica strip. Actually, it would seem to me that this would be the fuse. Either way, I'm not going to be able to get parts for this unit. Well, we can't make it any worse, right? So, the fuse is in here, and that's loose. Oh, okay. Let's see what's going on in there. There's the fuse. And it looks like it's totally deteriorated in there. Oh, it's missing. Look at that. Totally blown. See that? That's the fuse. Or what's left of the fuse. That is weird looking. I don't know if I can get that out of that cap. No. That's just weird. And that screws down and hits in there. That may be the fuse material itself. And in there is like a little square or something. Oh yeah. Let's see if we got continuity from the inside of where the fuse goes to one of these prongs. There we are. And this one probably connects to the case. No? This one connects here. And from there, yeah, there's some other problem too though, because that one's not connecting to nothing. This is it. This is this. But this, let me put this back on here again a second. Let's see something. I'm going to put this on this side. Put it on the meter. This one on this side. Put it on the other side of the meter. And try to connect this to here. Okay, so it's the fuse. This coffee pot will be on, if we get it working, it's going to be on its last two legs. Because what will happen without a fuse, well, there's still a piece of fuse in there, but what would happen without a fuse is it'd burn up this heating element, but this heating element's about on its last leg anyway. Yes. It seems to be making some kind of contact. There we go. Okay, so it should be all right because the fuse is, there's still a piece of fuse in there. Found some tape. Okay. And there it is. Oh wow, that is nice. Let's see why she likes it. Still got a piece of tape in there. Get that out. Okay, that's not the right insert. This is not the right piece for this. Maybe if I push down. Okay, it's got to stay centered. If it flips over, it's definitely not the right piece. Alright, now to fix that so I can at least do a test, first off I got to set it on something metal to protect my mat. So this will be on here, and then I can take these that are broken and lay them together and just set them under the side to hold that up. Hopefully it's about the same thickness. Yeah, that'll hold it level. So I can do a test. I can put water in there, and we can do a test. I'm going to have to get another line cord, so let me see if I got a line cord that'll fit that. And let's see if we got one of these that'll fit it. That's one that I had to disassemble. This doesn't look like the right size. It's 10 amp though, if it'll go on there. Oh yeah, that fits. I'm making contact. We will find out. Get the meter back. Yep, that one works. So we'll use it. Alright, I'm gonna have to put some water in here. Well, basically, I just want to see if it gets hot, but I got to put water in it because I don't want to burn it up. I don't burn out the rest of that fuse. Looking at the fuse, it looks like it's okay. It didn't look like it was totally burnt through, but part of it was, it had burnt at one point. Okay, I'm going to get a cup of water to pour in there, and we will try this. I'll be right back. Okay, I put about 12 ounces of water in there, just enough to see if it heats up. I don't know if it'll percolate, but we'll see what happens. Well, I didn't blow a fuse, so that's a good sign. Ah, it's getting warm. Hear it? It's warm up to here. Here it goes, it's percolating. You see that? Ah, she blows. Okay, so part of the problem was the fuse is shot and was too small. I had to screw it in and unplug it because I don't want to get so hot I can't move it. The other part of the problem is the cord itself is no good. This cord is no good. So what we're going to have to do, this is not the right cord for this. It does, ouch, that is hot. And I need to let that balance there until it cools off because I don't want to get burnt with it. It's still percolating, even unplugged. I just did what I said I didn't want to do, is knock that off there. I'm going to have to figure out how to make a leg for it though now. Ah, there we go. Let it cool off. Yeah, I'm going to have to figure out how to make a leg for it. This is a polarized plug cord, so it's not made for this. It is a 10-watt cord, so it'll hold this. This is only, I think this was, what, 8 watts? Yeah, 8 watts, the original. So this is a much better cord, and it's in good shape. And what it says on here is it's an HPN 105 degrees centigrade. That's really good. 18 gauge tube conductor, heater cord. So this is a good cord, and it's still flexible. It is vintage, but it's not that old because it's polarized. So it's relatively new plug. You know, they don't make those anymore. Unfortunately, it's not the best. I can't do much until that cools off because I'll get burnt, and I don't want to get burnt. How's this? Is this really hot? Let's take that off. Oop. So this here slides into the bottom, and you got to push it down a good amount to get it to stay straight up, but it does work, and it will percolate through that. So the next thing is trying to figure out what to replace this with. It wasn't part of the plan for it to get damaged in shipping, but you know, that happens. And it probably was more just wrapped tight. You know, they're so dry and old that they're brittle, and just wrapping it tight might have just folded it or put pressure on it, and then when it bounced or something, it just shattered. And it didn't just like break off, it literally shattered. There was little pieces, see? So it just totally disintegrated. I'll have to find some heat resistant element that I can put on there. It has to be something that can stand the heat. I can't match this rivet. There's no way. I don't have rivets like that. So, and unfortunately it's on the spout side. It'd be nice if it was on one side or the other where you could put it in the back, but it's right where the spout is, so it's going to be noticeable. And there's no matching that rivet. It's ancient, right? And it was a special crimping tool and all of that. It probably was done on a machine, and I don't have that. All I have is standard rivets that they sell today, and they're not the most aesthetically pleasing devices, you know. Rivets are rivets, right? So I have to find something. I would like to replace all three because the other two are brittle too, but then again, then we have three of these nice looking rivets. The only other thing I could use is, well, I don't have any stainless steel bolts, but stainless steel screws and nuts that have a nice smooth flat head would look nice. But I don't have anything like that. So I would have to try to find something like that. Okay, I'm going to go ahead. This has cooled down enough. I'm going to go ahead and empty it, and I'll be back. And we'll talk about the base. Okay, we talked about the rivet issue, and there's the back of the original rivets, and you see they are stainless steel rivets, so that's a special machine to put them in, and they don't make those rivets anymore. One of the other things I wanted to talk about was, you know, the fact that this thing shattered like that in shipping. You notice how this inside tray has an edge cut out to go around this. And you can see it on this one. It's cut out to go around this. It sets inside and it just wraps around these legs. Okay, but this is the pry hole to pry it out. And you notice how they put the pry hole right in line with one of the legs. And see, there's the thing to wrap around the leg, right? So they intended for you, when you change the fuse, to pry against that leg to pop it out. If they didn't want you to pry against the leg, it gives you leverage, right? Because you're up, let me get a screwdriver. You're up higher on the top of that leg. You're up here somewhere. And so that gives you leverage to pop it out, where down here it's not as much leverage. That's why they didn't put the hole over here, you know, where you could pry here, because there's not as much leverage. And when you try to pull up, you see what happens. This edge here would come up and hit whatever you're using, a screwdriver or whatever, to pry it up. It's going to hit it, so you have no leverage. So the only way to get it where you could pop it out easily is to pry on the leg and pop it up, because then if the hole was here, see, you're up high, and when you pry down, the edge here has room to come up without hitting the screwdriver because there's a notch cut out of it. So these were made strong enough originally to pry up against. It could be, well, when I took this off, this was lined up with this hole here. I think it was this one, might have been that one, but I think it was this one. It wasn't lined up with the one that was broke. My thought was it could be possible that it was originally lined up with the one that was broke. Somebody had pried it to check the fuse, and in prying it, they hurt it and cracked it. And so then when they put the cover on, they put it back in a different position. And when it was shipped, it was already cracked, and so it broke. That's possible, because these seem pretty strong here. I don't want to break them, but, you know, I'm looking at them, and they don't seem like they're going to shatter. But that doesn't mean anything. If that was the case, that is very well possible that somebody pried on it and cracked through it. But you see the separation in there, right? You see how it's like deformed? It's not flat, it's like twisted. It should be flat, right? It should be level. It shouldn't be half round. You see how it's half round? So it's almost like somebody might have pried against it and actually pushed way too hard and snapped it or cracked it. And to cover it up, or so it wouldn't happen and make it worse, they turned this. But if that's the case, it was already damaged enough that just shipping it was enough to kick it over the edge, and it shattered. And that's a possibility, in which case these won't shatter anytime soon, even though they look really worn. I mean, it is old, right? And it stands on these. It stands on these three with all the weight of all that hot water, and this being red hot. It stands on all three of those, and it's been doing that for many, many years. So it could be that these are bad and going to break, but it could be that they're fine and somebody just cracked that one. Someone was obviously in there trying to work on it. Well, anyway, long story short, the only thing I know I can do or know to do, and I don't know that I can do it, is try to find something that'll work, mimic one of these, and put it over here with a modern day rivet, because I'd have to drill this rivet out, assuming I can even drill it out. Stainless steel. Yeah, I think I can cut that off with a, if I can't drill it off, I can cut it off to get it out. And then put either a stainless steel bolt with a nice looking, some kind of nice looking head, and I don't, again, we live in the day of junk from China, so nothing's made in the United States. Trying to find something that looks nice is not going to happen, but I can try. I can go to Lowe's, they got a big hardware section, and check out their hardware section. It's all junk from China, but see if they got something that was that stainless steel that would look pretty good, and change that one. And what I'll upload this video and have the owner look at it, and then she can decide when I show her what I did, if she likes it and wants me to go ahead and replace the other two so that all three match. That'll be an option. It'd be an expensive option because of the amount of labor involved. It's going to be a lot of labor just creating this, right? But it needs it. It's no good like this. You know, it's no good like that. It has to stand up straight. It can't be leaning, and this gets hot, so it can't be touching the surface. You know, what else could be done? I don't know. I really don't know. That's the way it's designed. It's a nice looking pot. I mean, it could be put on a piece of glass tile, ceramic tile, and just, you know, underneath one side, and just glue it on the bottom here so that it stands up like that on some kind of glass tile that would stay relatively cool and be like a hot pad, you know, ceramic tile hot pads that you use in the kitchen. That would be the cheapest way to go. Just glue something underneath the bottom, but the glue would probably let go from heat over, you know, so that's why they rivet it, right? Anyway, that's where we're at. So if you found this video interesting, please consider giving it a thumbs up. And if I do go ahead and design something for this, we'll take another look at it and look at what it is. And in the meantime, I think this is a good replacement plug for this. It is a new plug. It's a new old stock plug that I had. It's not, but you can tell it's not been used. It is new. It's just a new old stock that I bought. I could sell that. It does fit on there pretty good. You know, it's not the original, so it doesn't. When you put the original on, you'll see the difference. I don't know, it may not be any different at all. No, it's not any different. It looks the same. Okay, see, and this is even more wobbly, and that's just not good. And I can't repair this because, well, I could, but I would have to drill these rivets out, and there's no sense in putting this old cord on there, back on there, when this cord is a better rated cord, you know, and newer, and has a one-way plug. Not that that would matter. I don't know why they put a polarized plug on here, but they did. That's just the way the factory made it. They made it with a polarized plug. The good thing about it is it's old enough that I think it's probably made in Europe and not China. I mean, I can buy a brand new one for you, for the owner, but if I bought a brand new one, it's going to be made in China, and it won't be as good as this. This looks like it was made in Europe, I believe so. I know it wasn't made in the United States, it's not old enough. But you see that in there, UE221, and then above it, it has, I think that's UE, so United Europe, I believe it's a European plug, made plug. Anyway, it looks well made, and you know, it's bolted together, and the contacts are clean in there. They look original. So anyway, that's an option. Well, anyway, thanks for watching, and like I said, if when I get this resolved, then we'll do a follow-up video on it. Never know what you're going to see here at Electro Restore. Have a great day. All right, the coffee pot is now ready, and we got a new cord for it. We got a new leg on it. Can you tell which one it is? It's this one here. And you see the rivets the same. What we did, or what we did is we made a new leg for it. We actually created a new leg. We had to buy some material and cut it to shape. It needed to be something that would handle the temperature, and it is, and it needed to be painted. And then we drilled a hole in it and put it in there. Of course, the rivet had to be drilled out of the old one, where the old one was. So what we did is we drilled it out from behind, but we didn't drill all the way through it so that we could actually reuse it. So we epoxied the new leg to the inside of this rim using 2-part epoxy. And you can't tell, but it's got 2-part epoxy. And then we put the rivet through it, even though we couldn't crimp it anymore because we had to drill it. But we put the rivet through it, and we epoxied the rivet in it for extra stability. So it is super strong, and no one's going to know. In fact, it just looks really well. It looks like the original leg. So no one would know without actually investigating and checking it out. So there you have it. There's the coffee pot back together, and with the additional line cord that's going with it, it's ready to go back to its customer. So there we have another repair of an interesting issue. And so, you know, some of these things can be repaired that are damaged by us, and some things, of course, are beyond the scope of what we can manufacture. But this coffee pot's ready for another 50 years of service. Thanks for watching.